Hi guys. So I'm not there, but I'm going to be here with you through video and uh, I will likely be able to answer any questions that you have if you decide to message me through um, Classroom. So I'm going to walk through what it is you're going to be doing today. Your assignment's going to be at the top of your stream, or you can also find it in classwork under ecology at the top, catastrophic events project. Okay, so when you open the catastrophic events project, it's going to give you the overview of the instructions. It says you're going to work with your table partners. Okay, that's for all aspects of this project. The timeline, today, Friday is day one. You're going to read the directions, research some designs, start sketching ideas. Okay, take pictures of your sketches. That way, if the sketches get lost, you still have it. Monday, Tuesday, and Wednesday of next week will be days 2, 3, and 4. So on Monday, you'll finish sketching any designs, plan who's going to build what parts, start building, take pictures. Okay, Tuesday, continue building, start testing. Okay, the testing is going to be with a hairdryer. Basically, if I can blow your structure over with a hairdryer, it doesn't pass. You're going to have to rebuild and try again. Okay, so if it doesn't pass, you're going to work on rebuilds and take pictures. Okay, day 4 is the last day for redesigning, rebuilding, retesting, and then you're going to start putting together your presentation during the last half of class. Okay, on Thursday, we'll finish your presentation the first 15 minutes of class, and then you're going to present. Okay, so all of this is pictures, pictures, pictures for your proof of what you've done. Okay, now the details. Okay, catastrophic events STEM lesson. Millions of people live in places around the world where hurricanes and or tornadoes are common. Up here we tend to have tornadoes. The most common structural damage is found in people's homes, buildings, and roadways. By designing buildings and other structures that can withstand the high winds and flooding associated with tornadoes and or hurricanes, engineers can save lives. So this is an engineering project. Okay, the hurricane of 1900 in Galveston, Texas was the worst natural disaster in American history. It killed nearly 8,000 people, mainly due to storm surge from the hurricane. Storm surge is flooding caused by hurricane winds pushing the ocean water to land. When Hurricane Harvey made landfall in August of 2017, I actually lived in Houston then, it's a Category 4 hurricane. It was the country's first major Category 3 or higher hurricane since Wilma hit Florida in 2005. And it's the first major hurricane to strike southern Texas since Celia in 1970. That was before me. So Harvey caused about $125 billion in damage and ranks as the second most costly hurricane to hit the U.S. mainland since 1900. Closer to home, and more recently, we had an outbreak of tornadoes hit DFW on October 20th, 2019. So that was this year. Many buildings and trees were severely damaged or destroyed in these terrifying events that happened just after dark that evening. The state of Texas is concerned because of the increasing frequency of hurricanes along our coastline and tornadoes in Tornado Alley, which we're a part of. You're the CEO of Hold Tight Engineering and have been asked by the state of Texas to design a home that can withstand the high winds and flooding associated with tornadoes and or hurricanes. You will be designing a model of a home that's a minimum of 15 centimeters in height and that can survive for at least 10 seconds. That makes no sense. Let's fix that. For at least 10 seconds. Your team will build a structure that can survive a simulated catastrophic event. You'll work through the 7-step process called the engineering design process. As part of step 7, communicate, you'll create a presentation that describes the steps you took to determine which design is the most stable. So this is partly where your pictures are going to come into play, right? Show us what you're doing. Your presentation to the class should include things like designs you brainstormed, design you chose and why, steps you took to create your model, pictures along the way could be helpful, what parts worked well, what parts needed to be redesigned, and finally your results. You can do this with a poster, you can do it with Google Drawings, you can do it with slides, whatever it is, you need to include your pictures though. Okay, criteria, you may not use more materials than what's indicated, what's provided. The structure has to stand without coming apart for at least 10 seconds while experiencing the wind event, me blowing a hairdryer on it. The structure has to be at least 15 centimeters tall, has to have a roof, and be freestanding. Okay, materials, 50 index cards, plastic grocery bag, notebook paper, Scotch tape. Okay, scissors and ruler can be used to help construct it, but they're not part of your structure. The grading scale, your plans or your designs are going to be 20 points. Okay. Following the directions is worth 40 points. Your teamwork is worth 20 points and your presentation is worth 20 points. If you have questions, message me on Classroom or send me an email. My email address is on the board if you don't have it. For your research component, I would recommend starting with these links in here and then branch out. Look for hurricane resistant designs, tornado resistant designs, building designs to withstand high winds. Any of that would be good starting points. Work with your teammates. Maybe one of you focuses on designs that withstand hurricanes. One of you focuses on designs that withstand tornadoes. One of you focuses on high wind designs. So collaborate, work together, piece it out. By the end of class today, you should have at least one design. Each person should be able to start sketching something, and then on Monday you can start putting it together to make a cohesive design. Best of luck. I'll see you Monday.